This nice little picture here, and basically underneath the graph here, the area here represents the total number of people, but we want to actually find something that says what's the percentage of people, so we don't necessarily want to bother with how many people there are and then change it to percentage. We want to know the percentage right away from the start. It's important we get a number of particular values. We want the mean and the standard deviation for the whole of the distribution, and then we're going to go doc, insert a graph. So I'm actually going to draw the Gauss graph to try and represent the percentage of people in various categories. So we've got to type in norm PDF, open a bracket. We just need the mean and the standard deviation. We also need the variable we're measuring, x, and let's see what we've got. So you see this flat line here, but of course we want to actually look at the proper variables here. This is the x-axis, this is the IQ score. I think if you go back to this picture, IQ scores from 70 to 210 would be good. So we want 70 to 210. So let's have a look. Menu, window zoom, window settings. So 70 to 210. Now on the y-axis, what's actually being plotted is the probabilities. And the probabilities are going to be certainly no more than 1. But you've got to choose actually quite a small number. And let's have a look. Negative 0.1, and we'll go up to 0.2 to start with, and we'll see what happens. Okay. So here's our function that models the percentage of people in certain sections of the IQ score. Okay. I'm going to change this now and make it a bit smaller. 0.05. And the bottom number here, negative 0.01. Okay, so at the moment you might be wondering, well, what does this look like? What does it mean? Well, compare it with this particular picture we've already got. Okay, it's the same shape. I mean, the numbers here are completely representing different things. This was how many people, so underneath the graph was talking about how many people. But now underneath the graph actually is the area underneath the graph represents the probability or the percentage of people. So if we go back to one of the questions we wanted to ask here, description. What percentage of the population have a score greater than 170? Okay, well I'm going to try and fill in this little point here, the percentage using the normal PDF. Okay, so using our model, let's go and have a look. Greater than 170. So go back to TI Inspire. So on here I'm going to do menu, I'm going to analyse the graph, and I'm just going to find the integral. Now integral is a fancy word for find the area under the graph. So find the area, and can you see down here it's telling me what's your lower bound? Well, the lower bound is 170, and what's the upper bound? Well, the upper bound is 210, and the integral here says it's 11%. So for our model, it says 11% of the entire population have an IQ score between 170 and 210. So if we go back to our sheet now, between 170 and 210, greater 170 was 11%. Now if we go and compare that back to the actual original histogram, I've got some answers filled in here. Here the original estimate from our table of data and from our picture here, the original estimate was 10.6%. Okay, so using the exact numbers, it was 0.106, which is 10.6%, and using our model, we've got 11%. So the old one was 10.6%, yeah, which equals 0.106, and using our model, we've got an estimate of 0.11. Okay, so with that, now you go and try and produce your model on your TI Inspire, and then try and answer the following 3 questions. And then, as an extra thinker, can you try and fill in this column, or at least talk about how close is the model prediction of 0.11 to the actual value of 0.106, and what's the most effective way of measuring the actual accuracy of the model?